Good evening, children.
Good evening, ma'am.
Good evening,
ma'am.
Hi, children. Good evening.
Good evening.
Good evening, ma'am. Oh, sorry. Good evening, children. Yeah, I shared an assignment on number systems. You can see it on the screen. Have you all completed this?
Yes, ma'am. Yes, ma'am.
Very
Yes,
good.
ma'am.
Yeah. Now keep your answers open. Keep your assignment with you. I shall be showing the answers one by one. Wherever you have gone wrong or, you don't understand, please ask me. And also I will upload the answers in the portal. So it will be there. You don't have to take screenshots or something. Supposing you're wrong and you want the correct answer, you don't have to take trouble by taking the screenshots. I'm going to upload the answers in the portal. So you can go to the portal and you can see the answers there. You can log into your portal and see the answers there. Okay, so let's begin. See the first one, children. Okay. Yeah, I'll not talk, so I'll just wait for some time. Check your answers. Tell me, genuinely, raise your hands, children. How many of you have tried the questions? You may not have attempted questions where you have a doubt or something, but at least you should have tried completing the assignment. How many of you? Be true to yourself. Swati, Abhishek, Bhavishya, Laksha, Anugraha, and Prenu. So all of you in the meeting today have completed, and Aniruddhan. Okay. All of you have completed. Oh, very nice. Okay, children. Yeah. Yes. I'll just wait for some time. Check your answers. And if it doesn't match with my answer, you can ask me. Any questions? Any doubts here?
No doubts, ma'am. No, ma'am.
Did you all check your answers? All the answers?
Yes, ma'am. Yes, ma'am.
Okay. See, there's the next one. Oh, I forgot the minus sign here. Sorry. So what is this? 2 into cube root of 125. So 2 into cube root of 125 is 125 can be written as 5 cubed. 125 is 5 cubed. So the cube root of 5 cubed is 5. It's 5 into 5 into 5. Under the cube root, it is 5 into 5 into 5. So from 3 5s, 1 5 comes out. So it is 2 into cube root of 5 into 5 into 5. So from 3 5s, 1 5 comes out. 2 5s are 10. And here also 0.5 should be written as 5 by 10. 0.5 is 5 by 10. And 5 by 10 is 1 by 2. 625 can be written as 25 square. So 2 and 2 will get cancelled. 25. So the expression is rational. Okay, children. Any questions here?
No doubts, ma'am. No doubts, ma'am.
Yeah. Here also you can see 14641 is 11 into 11 into 11 into 11. Cube root of 14,641 is 11 into 11 into 11 into 11. So you have to do this method. 14641, 11, 1331 times 11, 121 times 11, 11 times 11 ones. So from 3 11s, 111 comes out. From 3 11s, 111 comes out. So the other 11 remains under the cube root by cube root of 11. So this one and this one gets cancelled. So 11 is the answer. Therefore, it is rational. Or you can also do it like this. You can write it as cube root of 14,641 by 11. Instead of using the cube root symbol separately, you can write cube root of 14,641 by 11. So again, the same thing. Now 11 and 11 will get cancelled. So now from 3 11s, 1 11 will come out. So it's rational. Here when you open the bracket, minus 12 minus root 7. So root 7 minus root 7 gets cancelled. Minus 11 minus 12 is minus 23 and it's rational. This one is a terminating decimal, so it's rational. This one is a non-terminating, non-repeating decimal. So it's irrational. 0.1 recurring. It's a non-terminating but repeating decimal, so it's rational. Pi has a non-terminating, non-repeating decimal expansion. The decimal expansion of pi is non-terminating, non-repeating, so it's irrational. But when you say 22 by 7, it has a p by q form, so it is rational. 22 by 7 is rational because p by q form. But pi is irrational because it's decimal expansion. The decimal expansion of pi is non-terminating, non-repeating. So pi is irrational. But when we use the formula pi r square, for pi we use 22 by 7. That's not the exact value of pi. Because pi has a non-terminating, non-repeating decimal expansion, it doesn't have a p by q form at all. Because the decimal expansion of pi is non-terminating, non-repeating, it does not have a p by q form at all. But for calculation purpose, you have to find some value. No, you cannot use a non-terminating, non-repeating value for calculation. So it's approximately equal to 22 by 7, or we take it as approximately 3.14. It's not exactly equal to this. It's approximately 22 by 7 or 3.14. So remember that because pi has a non-terminating, non-repeating decimal expansion, it does not have a p by q form. But while finding in formula where we have pi, we take pi as 22 by 7 for the convenience in calculating. For the convenience in calculating, not that pi is equal to 22 by 7. Or sometimes it's given that pi is equal to 3.14. These are approximate values. Is it fine, children?
Yes, ma'am.
All of you?
Okay, ma'am.
Yes, ma'am.
Now tell me, is pi rational or irrational pi?
Irrational, ma'am.
Irrational.
Why do you say pi is irrational? Why is pi irrational?
Because it has non-terminating and non-recurring decimal expansion.
Yeah, because it has a non-terminating, non-repeating decimal expansion. What about 22 by 7? Is it rational or irrational?
Rational.
Why?
And because it is in a P by Q form.
Yeah, because it has a p by q form, integer by integer form. So 22 by 7 is rational. Very good. See the next answers. Check and then I'll talk. Okay, so this one is a terminating decimal. So here you'll have to classify as terminating, non-terminating, repeating, non-terminating, non-repeating. So this one is terminating. This one is non-terminating, repeating. Here you will have to find the value. It's 9. So it's a terminating decimal. 9 means 9.0. This is non-terminating, repeating. Here you'll have to simplify. So how to simplify? You can see it here. So fifth root of 32 can be written as 32 to the power 1 by 5. And 32 is 2 to the power 5. 32 is 2 to the power 5. And there's already a power 1 by 5. So you'll have to multiply the powers. So 5 cancels and it's 2. You all remember, right? How to write the radical form and the exponential form? Fifth root of 32 can be written as 32 to the power 1 by 5. Cube root of 27 can be written as 27 to the power 1 by 3. That's what I've written here. These are in the radical form. I've changed them or put them in the exponential form. Then the base 32 can be written as 2 to the power 5. The base 27 can be written as 3 cubed. But there's already a power 1 by 5 and 1 by 3. So multiply the powers. Then they get cancelled. So 2 by 3. Now the question is it a terminating decimal or a non-terminating repeating decimal or a non-terminating non-repeating decimal? So when you divide 2 by 3, when you divide 2 by 3, you get 0.66666. It goes on. So it's a non-terminating repeating decimal. This one is non-terminating, non-repeating. This one is non-terminating, repeating because 2939, again 2939. 2939, again 2939. So that means it's repeating. It is 189.2939 recurring. 189.2939 recurring. So it's a non-terminating repeating decimal. Any questions, children?
No, ma'am.
All of you? Okay. Every rational number is a
Real number. Real number.
Every rational number is a real number. Very good. Which of the following is a rational number?
0.75 bar. C.
This one, huh?
Yes, ma'am.
Yeah, correct. Because this one is non-terminate. This one has a non-terminating, non-repeating decimal expansion. Irrational. This one is also irrational. This one is irrational because non-terminating, non-repeating. 750, 7,500, 75,000. So 7510, 7520, 7530. So it will be 7540. Non-repeating. This one is a non-terminating but repeating decimal. So it's rational. Very good. True or false?
False. False, ma'am.
It's not a rational number. So that means you're saying it's a rational number?
Ma'am, it's true.
No, let me understand. Is it rational or irrational?
It's a rational number, ma'am. It's not a rational.
Who says it's rational?
Niveta.
Niveda. Yeah, Niveda. Tell me, why is it rational? Root 18 by root 8. How do you say that it's rational?
When I take the prime factors, I will be doing the prime factors. I will be getting 3 root 2 by 2 root 2. So 3 by 2.
Very good. Very good. Very good, Niveda. We should always simplify and then, decide if it is rational or irrational. As Niveda rightly said, root 8, you can simplify in many ways. Root 18 by root 8, you can write it as root of 18 by 8 also. Because numerator is also square root, denominator also square root. So you can write it as root of 18 by 8. So that is equal to root of 9 by, what is it? 2 9s are 18, 2 4s are 8. So 9 by 4, which is equal to 3 by 2. Square root of 9 is 3, square root of 4 is 2. So 3 by 2. You can do it like this, or like Niveda said, root 18 by root 8 is equal to, this is 3 root 2. This one is 2 root 2. So root 2 gets cancelled. So 3 by 2. Anyways. So say like somebody is telling that root 18 by root 8 is not a rational number because root 18 and root 8 are not integers. Because what is a rational number? Integer by integer is a rational number. Root 8 is not an integer. Root 18 is not an integer. Root 8 is also not an integer. So they are saying that it's not a rational number. But it's false because on simplifying we get 3 by 2. So since root 18 by root 8 is equal to 3 by 2, 3 by 2 is a rational number. So this one is also a rational number. All of you, very important. Very, very important. I'll give you time because it's very important. Write down this answer. Please write down, children. If you have gone wrong, practice this now.
But there is a condition that root 18 and root 8 are not integers. So that condition is true, no, ma'am?
No, like you just imagine, I'm telling you, Swati, root 18 by root 8 is not a rational number. The reason I'm giving for that is, see, I'm telling you, Swati, I think root 18 by root 8 is not a rational number, Swati, because rational number means P by Q form, where P and Q are integers. So I'm telling you the numerator root 18 is not an integer. The denominator root 8 is also not an integer. So I'm saying, Swati, so because numerator and denominator, they're not integers, it is not a rational number. So what will you tell me? You will say, no, it's not like that. You must take up the expression given and simplify. You must not just look at what is given. Root 18, root 8 as it is, you should not take the value. You will tell me, you please simplify first. What do you get on simplifying? I'll say I got 3 by 2. Now check if this one has a integer by integer form. Yeah, this on after simplifying, we get an integer by integer form. Then you'll ask me, is 3 an integer, 2 an integer? Yes. So then 3 by 2 is a rational number. If 3 by 2 is a rational number, then the given expression is also a rational number. You understand?
Yes, ma'am.
This is like somebody is telling you. They are telling you that root 18 by root 8, it's not rational because they are giving you the reason. The reason they are giving you that it's not rational is because the numerator root 18 is not an integer. Denominator is also not an integer. Then if it's not integer by integer, then it's not a rational number. So you will say that no, that's not the way you check. You should simplify what is given. See, in that case, Swati, see, like if I say root 16. Okay, now supposing I say root 16 by root 9. Root 16 is not an integer. Then root 9 is also not an integer. Therefore, it is not rational, I'm saying. So you will say, no, what is the square root of 16? 4. What's the square root of 9? 3. 4 by 3. This is integer by integer, so it's a rational number. Understand?
Yes, ma'am.
Yeah. This is somebody's reason. This is somebody's reason. Somebody is telling you that because they are not integers, this one is not rational. So you will tell them that no, you first simplify it. On simplifying, see, you're getting 3 by 2. So it's a rational number. All right.
Yes, ma'am.
Very important question. Very important. For 2 marks, the first question will be something like this. Always simplify. To check if a given expression is rational or irrational, you have to simplify. Yeah. See, you can get different answers, children. I'll just explain what I have done. So between these two numbers, I have written 0.01, 0.02, 0.03. What is 0.01? 1 by 100. This is 2 by 100. This is 3 by 100. And then wherever it is possible to simplify, you should simplify. 2 ones are 250 times. So 1 by 50. You can have different answers. So these you check when I share the answers there. These answers you please check once I share it there. Because it's not a unique, the answers are not unique, no, that's why. Inserting rational numbers, the answers are not unique. So you please check when I upload the answers in the portal. Yeah. What is the decimal expansion of 15 by 7, children?
2.142857 bar.
1 second. Yeah,
2.142857 bar.
Correct. What is 11 by 24?
Ma'am,
It's
0.461, ma'am.
0.4?
61, ma'am.
No.
0.4583 bar.
Bar is on top of how many
3
digits?
ma'am.
Okay, correct. Yeah, please see the division. Check your division. Yeah, next one. This is the division. Anirudh, see where you've gone wrong. Children, just a minute, I'll come back. Anirudh, where have you gone wrong with the division?
Ma'am, I wrongly minus the 110 and 96.
As
And I
4,
got
is it?
what, ma'am?
You wrote 4 instead of 14?
16 I wrote, ma'am, instead of 14.
Okay, that's why you went wrong. All right. Okay, fine. Children, see, I'm not explaining all this because division you all know, so I don't have anything to say. Okay, then without actual division, find which of the following will have a terminating decimal expansion. So if you've forgotten, I'll just explain again. Yes, children. So how do you, without division, see the question, without actual division, you must just look at this and say if it has a terminating decimal expansion or not. So for that, the procedure is first put the fraction in the simplest form. That's the first step. Simplify it. So 3 5s are 15, 3 3s are 9, 3 2s are 6. So 5 by 32. First put the given fraction in the simplest form. Okay, so we get 5 by 32. Now take the denominator and find the prime factors of the denominator. So 32 can be written as 2 to the power 5. 2 to the power 5 is nothing but 2 to the power 5 into 5 to the power 0. So you see that the denominator has only 2 as a prime factor. What is the rule? The denominator can have only 2 or 5 or both 2 and 5 as primes. The denominator should have either 2 or 5 or both 2 and 5 as primes. Then it will have a terminating decimal expansion. If there is any factor other than 2 or 5, supposing there is a 3 or a 7 or 11, then it will have a non-terminating repeating decimal expansion. It cannot have a non-terminating, non-repeating decimal expansion because it's a P by Q form. So P by Q cannot have non-terminating, non-repeating decimal expansion. Step 1, simplify 5 by 32. Step 2, prime factorization 2 to the power 5. Step 3, 2 to the power 5 into what is not there, 5 is not there. So 5 to the power 0. If it's okay if you don't write the step also. I normally write it. It's okay if you don't write it also. You can conclude here itself. So the denominator has only 2 as a prime factor. So terminating decimal expansion. On either 2 or 5 or both 2 and 5. Nothing other than 2 or 5. So 2 to the power 5. I write it like this. Because 5 is not there, 5 to the power 0. So the denominator is in the form 2 to the power m into 5 to the power n, where m and n are whole numbers. Therefore, it has a terminating decimal expansion. These are the steps. Next one, 27 by 80. Again, you must simplify if possible. Now, this one, it's not possible to simplify. You cannot simplify it. It's already in the simplest form. So then, don't find the prime factors of the numerator. That we don't want. We want only the prime factors of the denominator. Numerator, you don't have to write 3 cubed. We have to put the expression in the simplest form and then factorize only the denominator. You don't have to factorize the numerator. So look at the denominator, only 2 and 5 factors, only 2 and 5. So denominator is in this form where m and n are whole numbers, terminating decimal. So how did we say that it has a terminating decimal expansion without actually using the long division. Without the long division. Understand? Do we all understand,
Yes,
children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Find the decimal expansion of, okay, let me ask somebody. Sadhana, what are we discussing, Sadhana?
Ma'am,
What are we doing in the class now? We are discussing the answers to what?
we discussed the answer till without actual division. You have to find the decimal expansion.
No, sorry. No. Like we're discussing some answers, right? What is this we are discussing?
From the assignment.
Which assignment? When did I give? When did I send the assignment on WhatsApp?
No, ma'am.
Then where was the assignment?
It was in the app.
Atar portal, huh? Okay, fine. Have you both completed the assignment?
Yes, ma'am. Yes, ma'am.
Okay, fine. All right, girls. Yeah. Find the decimal expansion of 100 by 101 by performing the long division. Abhishek, what is the decimal expansion of 100 by 101? Prenu? Who can tell me?
Can I?
Yeah, tell me.
It's 0.9900 bar.
0.9900 bar. Huh?
Yes, ma'am.
Very good. Very good. So it's not possible to divide. So 0. So how I do is no 101 0 times is 0. See my division. I'll tell you how to understand. 101 zeros are 0. So the remainder is 100. The remainder is 100. Then after that you don't have any digits. No, so keep a point and add a 0. 9s are 909. The remainder is 91. Add a 0. Again, 9s are 909. Remainder 10. Sorry, 1. Sorry, not 10. 1. Remainder 1. Add a 0. Now 101 zeros are. See, you can use 101 into 1 is 101. Or you can use 101 into 0 is 0. You can use this also. This is also tables. No, 101 into 0 is 0. So when you have 10 here, 101 into 0 is 0. So 10 is a remainder now. Now 10 is a remainder. You can add one free 0. 101 zeros are 0. Now 100 is a remainder. See, the remainder is repeating. No, here also we had 100 remainder. Again, the remainder is repeating. So again, you'll add a 0 and it will repeat. 0. Again, 9s are 909. The same steps will repeat. If the remainder repeats, you can stop there. If the remainder repeats, you can stop there. See, we'll do it here. See, children. 100 divided by 101. See, you should not write like this 101 here and 100 here. If you have done this division, it's wrong. The numerator will be the dividend. The denominator is a divisor. The numerator is a dividend. The denominator is a divisor. Now let's start the division. 101 zeros are 0 because 101 into 1 is 101. Now 100 is a remainder. Keep a point and add a 0 because there's no digit, no. So you'll have to add a 0. 9s are 909. Remainder 91. Add a 0. 9s are 909. Remainder 1. You can freely add 1 0 in every step. Now 101 and how many times is 10? The zeros are 101 into 0 is 0. Now 10 is a remainder. You can add 1 0 in every stage. Again 101 into 0 is 0. 100 is a remainder. You can add 1 free 0 every step. Again 9s are 909. 91 is a remainder. So the same thing will repeat. So it is 0.9900 recurring. That means 0.99000099009900. It goes on like this. And you must write the remainders at every stage. Show the remainders at different stages. You must show the remainders. So remainders are without the zeros. Because every stage you add a 0, no? Every stage we have added a 0. Just take away the zeros, they are the remainders. Okay, here I didn't add the 0. Okay. So these are the remainders at every stage. 100, 91, 110. Again 100 we are getting. So you can stop there. Again we are getting remainder 100. Okay. So the question is to find the decimal expansion of this one by performing the long division. So we have done the long division and we got the decimal expansion. We found the decimal expansion by long division. And show the remainders at the different stages alongside. So here in this state, the remainder is 100. In this state, the remainder is 91. In this state, the remainder is 1 and so on. Understood, children?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes.
Yeah, this again is division, children. Here I've not done the long division. I've just given the final results. You can check it later. I've not done the long division because write each of the following in the decimal form. Sometimes we have to divide. So you please check this later. Now the next one. A rational number between root 3 and root 5 is
2.
which one?
2, ma'am.
A, B, C, D,
C, ma'am.
C.
Yes, ma'am.
Okay.
C2.
What's the value of root 3? 1.7 and something, no? 1.732. What's the value of root 5?
2.236, ma'am.
2.236. And we have to find a rational number. We have to find a rational number between root 3 and root 5. So 2 is a rational number. See, between 1.732 and 2.236. Between this, you have 2, and 2 is a rational number. 2.5 is also a rational number, but it is not between these two numbers. What is root 3? 1.732. This one is 2.234. You should know these values. 2.5 is not between these two. This is 2.2. This is 1.7. 2.5 is beyond this. So 2.5 is a rational number, but it's not between these two. So 2 is the correct answer. All right, children. Okay. Yeah, this is again a rational number between root 3 and root 11. Root 3 and root 11. Root 3 is 1.732. And root 11, even if you don't know, you know 3 3s are is 9. 4 4s are 16. So this one should be 3 point something. Sometimes you need not know the value, but you should at least know the approximation. Root 11. So we know root 9 is 3. So root 11 will be more than 3, but it will be less than 4. 3 point something. So what is a rational number between? This is 1.7 and this one is like 3 point something. So between these two is 2.5, not 1.5, because 1.5 does not lie between these two. This is 1.7, this is 3 point something. So 1.5 will be here, 1.5 will be here before 1.7. Between is only 2.5. So though both 2.5 and 1.5 are rational numbers, 1.5 does not lie between. 2.5 is a number that lies between root 3 and root 11. Am I clear, children?
Yes, ma'am.
Yes, ma'am.
Again, a rational number between root 2 and root 3. Is the question repeated? No, it's not. No, it's not repeated. It's between root 2 and root 3. Root 2 is approximately 1.4 and something. This is 1.7. So between these two is 1.5. So here in the options given, this is irrational. This is irrational. This is irrational. This one is rational. This one is also rational. So the question is here. This one cannot be the answer. This one cannot be the answer because they are irrational. This one is rational, so can be. This one is also rational, can be. This is 1.4, this is 1.7. So between 1.4 and 1.7 is 1.5, not 2.5. This may be a rational number, but it's not between these two numbers. So 1.5 is the answer. Is option A a rational number, children? Is option A a rational number, children?
No, ma'am.
No.
Ma'am.
Is option B a rational number?
No, ma'am.
No, ma'am.
Yeah, option A is not a rational number. Option B is also not a rational number. Is option C a rational number?
Yes, ma'am.
Yes,
Is
yes,
option D a rational number?
Yes, ma'am.
Yes, ma'am.
Yeah. So among the options given, A and B are irrational numbers. C and D are rational numbers. So answer cannot be A or B. Answer cannot be A or B. So you don't think about these two because you have to find a rational number. These two are not rational only. So leave those two. Now this is rational, this is rational. This one is 1.4 and something, this is 1.7 and something. So 1.5 will come in between. 2.5 is beyond 1.7. An irrational number between, I'll just come children, I'm getting a call, 1 second. Yeah, thank you, children. So now you have to find an irrational number. So is this irrational? No, this is not irrational. 5 plus 6 is 11. 11 by 2 is rational. So this cannot be the answer. This one cannot be the answer because it's rational. Now here in option C, what is 5 plus 6? It's 11. What is root 11? Approximately, it is 3 point something. Root 11 is approximately 3 point something because root 9 is 3. Root 16 is 4. It's like 3 point something. So though root 11 is irrational, its value is 3 point something and it's not between 5 and 6. Am I clear, children? Are you all following me?
Yes, ma'am.
Yes, ma'am.
Is option A rational or irrational?
Rational.
This is rational.
Rational.
So ignore this. Yeah, ignore this. Now, we are talking about this one. This one is nothing but root 11. And you know that root 11 is irrational. So we are trying to find its approximate value. Just guess its value. It will be like 3 point something, correct?
Yes, ma'am.
Now tell me what is root 50? It will be what point? Root 50 will be?
7 point something.
Yeah, 7 point something. Very good. Because 7 sevens are 49. Because root 49 is 7. So root 50 will be 7 point something. See, I'll tell you something. 1 minute. All of you listen carefully. Now root 16 to root 25. Okay. What are the numbers we have? Root 17, root 18, root 19, root 20, root 21, root 22, root 23, root 24. Okay. These are the numbers we have. Now root 16 is 4. Root 25 is 5. All these numbers will be 4 point something, 4 point something. 4 point what? I don't know. I don't know what is it, but it's 4 point something. It's not 5 point. It's 4 point something. Then here root 25 is 5. Now after root 25, root 26 will be 5 point something. Root 27 is 5 point something. Root 28 is 5 point something. Till root 36, because root 36 is 6. So till root 35, it will be 5 point something. Am I clear, children?
Yes, ma'am. Yes, ma'am.
Yeah. So I'm saying that this is not rational. Sorry, this is not irrational. And supposing we take up this one, this is root 11. Approximately it is 3 point something because it's more than root 9. So it's 3 point something. And that's not, so though this option is irrational, its value is not between 5 and 6. So this one is not possible. This one is not possible. Now this one. root 30. You can remember this as a rule, children. An irrational number between A and B is root AB. An irrational number between A and B is root AB. Root of 5 into 6. You can even check with its value. So now what is root 5 into 6? Root 30. And where is root 30? It is between root 25 and root 36. Where is root 30? It is between root 25 and root 36. Root 25 is 5 and this is 6. So this will be 5 point something. And clearly it's between 5 and 6. And it is irrational. See, there are two conditions. It should be irrational. It should be between 5 and 6. Two conditions you must satisfy. It should be irrational, not rational. And it should be between 5 and 6. So if you look at this option, root 5 into 6 is root 30. And root 30 is between root 25 and root 36. 25 is 5. Root 36 is 6. So between that you have root 30. So it will definitely be 5 point something. It will be a non-terminating, non-repeating decimal. It's irrational. So it's irrational and it is between 5 and 6. So the correct option is root of 5 into 6. Yeah, what's the answer for this one, children? No, all of you should participate now. Now P by Q form. Now this is the deciding factor. If you have done the homework, you should be able to give the answer for this. Abhishek? Abhishek?
Ma'am?
Yeah, what's the answer for this one? What's the P by Q form?
Ma'am, 2,218 by 1,000.
2,400. Okay, I'm going to write down your answers.
2,218
2,218
by 1,000.
by 1,000. Then, okay. If no, see, you should practice from your tuition notebook.
Ma'am, this sum, this 16 and 17 I didn't do, ma'am.
Why you didn't do? Why you didn't do?
Ma'am, I don't know the answer.
How you can say that? Haven't we done all this in the class? It's in your tuition classwork notebook. No, you must open your book and see the method. Only if you remember, you will do it, is it? You will not revise. Open your tuition notebook and see. I have done all this. You cannot be this careless, Abhishek. You are in your vacations now, right?
Yes, ma'am.
Then, very bad. This shows your irresponsibility in completing the homework. I'm spending time. I'm teaching from 6th standard to 10th standard. I'm spending time to prepare your assignments, prepare your answers, put it in the portal. I have to take care of my house plus do this. And you don't have time to take care of only your studies. If 2.218 recurring, this one is 2218 by 1,000. Then what is 2.218, Abhishek? What is the answer for this one?
Ma'am, it's 2,218 by 1,000.
Then what's the difference between the two numbers? According to you, both are the same. According to you, 2.218, this one recurring, and 2.218, both are the same. Yeah, somebody else. No, not somebody else. 1 minute. So Abhishek, not satisfied with your work. Anirudh, everything is in the tuition notebook. No assignment is given without teaching you the concept. Everything is taught. And based on what is taught to you, the assignment is prepared. Nobody can tell me that I don't know the answer to something. Yes, Anirudh, what is 2.218, Anirudh? Tell me. I'm asking a different. No, I'm asking you something else. Please listen to the question carefully. What is 2.218 equal to? The P by Q form.
Ma'am, in the P by Q form, 2.218 is 2218 divided by 1000.
Okay, then after this, we'll have to simplify, right?
Yes, ma'am.
Now tell me what is 2.218 recurring?
Ma'am, 2.218 recurring is 2196 divided by 9990.
9,990. You worked this in your book?
Yes, ma'am.
What about the others? Is this, are you getting the same answer?
No, ma'am, I got a different one.
What's your answer, Swati?
Ma'am, I got 2,216 by 999.
2,216 by 999.
Yes, ma'am.
Okay, Swati. Others? Yeah, share your answers, others. Niveda? Niveda, what's your answer?
Mom, I'm getting it wrong, I think so.
That's okay. Just share your answer. What have you got?
Mom, 2,207 by 999.
Yeah, Sahana and Sabarna. Sadhana and Sabarna.
Ma'am, I got 244 by 53.
By 52.
Yes, ma'am.
Yeah. Both of you got the same answer?
Ma'am, it's 245.
Okay. Sahana?
Ma'am, 1997 by 900.
Bhavishya?
I'm 122 by 55.
Anugraha?
Ma'am, I got 244 by 55.
244 by?
55.
Laksha? Laksha and Prenu. Prenu, what's your answer?
Ma'am, 244 by 55.
Very confidently you're saying this. And Laksha?
Ma'am, 2216 by 919.
No, I'm so disappointed. What's the point studying in the vacations, huh? You're all just doing whatever you feel is right. I'll have to check your books. Next class will be a physical class. I'll check your books. I'm very disappointed with all of you. With all of you. You have to refer. Assignment is not doing whatever comes to your mind at that time. You have to open the tuition classwork notebook, revise. Or even if you don't revise, when you encounter a question which you feel you've forgotten the procedure, you will have to open the tuition notebook, see, recall the procedure, understand, and then practice. And then work the homework. This is the correct answer. Please check, all of you. Whoever got this, you're right. And if you have not got it, those who have got a different answer, simplify. See if you have not simplified. That's all. So how many of you get this answer? 122 by 55. Bhavishya has got 122 by 55. Why did Anugraha get 244? It's 122. Maybe some reducing problem. You didn't reduce it probably. Some minor mistake you have made, Anugraha. Prenu also some minor mistake you have made. I don't know why 6 plus 1, 7 plus 2, 9. No. Swati and Laksha, I don't know why you're getting these answers. Who else got it? I don't see anybody else. 2,207. No. Bhavishya and Anugraha. Bhavishya is right. Anugraha, I think, is kind of close. Somewhere she's made some mistake with simplifying. Also, Prenu, you both need to check.
Ma'am, I did a mistake in the cancelling.
Okay, yeah. Now, Niveda, just tell me what you have done. X is equal to 2.2181818. Is this understood?
Yes, ma'am.
Yeah, then how many digits are repeating?
Ma'am, 2, but I had take like 2.218, 2.218 like that. I took 3 digits, ma'am.
2.218. Only 18 is recurring, no? The bar is not over 2. It's only over 1 and 8.
Okay, ma'am.
2.218 recurring. So how many digits? 2 digits are recurring. So you should find 100x. That's all. If 3 digits, if the repeating block has 3 digits, then 1000x. The repeating block. See the repeating block, 2.218. The bar is on top of 2 digits. So that means you should find 100x. X you already have. Then you should find one more. That is 100x. That's all. And subtract the 2. Is it so difficult?
No, ma'am.
Supposing we have x is equal to 13.13496 recurring. How many digits? The bar is on top of 1 digit. So you should have x and 10x. That's all. Subtract these two, you will get the answer. If the bar is on top of these 2 digits, 100x. Or these 3 digits, 1000x. These 4 digits, 10,000x. You should subtract x and 10,000x. That's all. Either it is 10x minus x or 100x minus x or 1000x minus x. So how do you decide 10, 100 or 1000? Depending on how many digits are repeating. So here 1, 8, 2 digits are repeating. So 100x. I don't want to discuss the P by Q form further because okay, then others will be disappointed. No, those who've done it correctly will be disappointed. Fine. Let me ask Bhavishya again. So that's about this answer. Bhavishya and Anugraha, Prenu. Prenu, what's the answer for 12.85?
Ma'am, 1285 by
Yeah, by? What happened? By? Anugraha?
Ma'am, I didn't do it because I had a doubt.
Bhavishya?
Ma'am, 12.85 is equal to 1285 by 100.
Yeah, then
By simplifying 257 by 20.
how much?
257 by 20 by simplifying 128 by 85 by 100.
What?
For first
What's the final answer?
for first one I got 257 by 20.
Okay.
12.85 recurring is 1273 by 99.
1273 by 99, is it?
Yes, ma'am.
Sahana, did you answer? Did I ask you, Sahana? Sahana. Okay, let me see. Anyone else wants to share the answer?
Ma'am,
Yeah.
for one. Ma'am, it's actually a mixed fraction. It's 17 by 20.
Oh, you can leave it like an improper fraction. It's okay. You don't have to write the mixed form. What is the improper fraction you got? Did you get this one?
Yes, ma'am.
Isn't it 257 by 20?
No, I think I don't have the answer for that. 1 minute. Okay, I don't have the answer for this one. Yeah, but I can tell you. Yeah, 257 by what?
By 20, ma'am.
257 divided by 20. Yeah, correct. It's by 20. What did you say, Bhavashya? 20 or 25?
20.
Oh, okay. Okay, children, most of all of you complete this one. We'll see the answers to this in the next class. All of you. The method, the procedure to work this is in your classwork book. We have done all this in the class. So all this, we'll check the answer in the next class. Oh. Okay, so that's the end of the first assignment. I have prepared, I think, 4 assignments for you. I asked you to do only the first one, right?
Yes, ma'am.
Sometimes, I would have uploaded the assignment, but it will not be visible. Like you can see 4 assignments, but only one will be visible to you. The other 2, you will not be able to open it. Don't worry about that. That's not only for you. So like when I prepare many assignments, if I make everything available for you, then you will not know which to finish. Okay, so you'll have a lot of questions like that. So whatever is your assignment, only that you will be able to access. You will be able to see many other things, but you will be able to open only with, like whatever I've asked you to do. The others you cannot open. It will just say that the content is available only next month or whatever. So don't worry about that. Finish the rest of the answers. We'll discuss the answers in the next class, children.
Okay.
All right. Children, please help me. What were we doing? What should we continue with? Did we start exponents, children?
No, ma'am.
No, I don't remember what we were doing in the last class. Just read the question, the last question. Somebody try to read the last question of the last class.
Ma'am, Anirudhan found the last question, ma'am, in the last class.
Tell me.
If x is equal to root 2 plus 1, root divided by root 2 minus 1 and y is equal to root 2 minus 1
Correct.
divided by
Thank you.
root 2.
Thank you. Thank you, Anirudhan. Yes, yes, yes. I understood which one. Okay, okay. It's this file. Okay. Oh, no, no, not this one. 1 second, 1 second. I think it's this one. This one, right, Anirudh?
Yes, ma'am.
Yeah, thank you. Children, did we answer this one or?
Yes, ma'am. We
Yes,
have
yes, yes.
answered and we have wrote the answers, ma'am.
Oh, very good, very good. Thank you so much. Fine, fine. So we have to continue from here. All right. This we have to do, right, Anirudh? This one we have not done.
Yes, ma'am. We have not done.
Okay, this is the next one then. Okay, children. So if x is equal to 1 by 3 minus root 8, find the value of x cube minus 2x square minus 7x plus 5. So the value of x is given. And you need to find the value of the expression x cube minus 2x square minus 7x plus 5. Okay. So as always, you know, whenever the denominator is irrational, we'll have to rationalize the denominator. That's the first step. Denominator is irrational, so we rationalize it. So you know that procedure. Okay, so till here. So x is equal to, after rationalizing the denominator, we get x is equal to 3 plus root 8. Because 9 minus 8 is 1. So 3 plus root 8. Now, after this, listen carefully, children. After this, have only a root 8 on one side because it is irrational. Have only root 8 on one side and take the 3 to the other side. This irrational part, you know, root 8, have that alone on one side and take this 3 to the other side. So x minus 3 is equal to root 8. Now, we square on both the sides. Why do we square on both the sides? Squaring on both sides. Now, why should we square on both the sides? Because we have to get rid of the square root symbol. Or we have to get rid of the square root. So we square on both the sides. So we square on both the sides. So now it's like a minus b the whole square. A square plus b square minus 2ab. A minus b the whole square is a square plus b square minus 2 into a into b, 2 into a into b is equal to 8. So 3 square is 9 and here 2ab is 6x. Now bring all the terms to one side. Now see the square root is gone. The square root symbol is gone. Now bring everything to one side and you can simplify 9 and minus 8. It's plus 1. So we have x square minus 6x plus 1 is equal to 0. Now, in order to find the value of this expression, we have to somehow connect this one and this one we have. Somehow we have to connect, only then we can get the value. So we're going to connect it using the long division. So by long division, how can you connect? Yeah, once you do the long division, if you take the bigger one, this x cube as a dividend, and the smaller one, this x square as a divisor, you can connect these two by the division algorithm. Dividend is equal to divisor into quotient plus remainder. You can connect it using the division algorithm. The next step, you want to connect this expression and this expression. You want to connect it somehow, you want to link it. So that like that you can find this value. So now how can you link it? So we are using the long division. We are dividing the larger one, that is this x cube. We are taking that as a dividend and we are taking this as the divisor, x square as a divisor. This expression as a divisor. The bigger one, x cube inside as a dividend x square outside as a divisor. And I'll teach you how to do this division. So, and then we perform the long division, the algebraic division. Now we get a remainder, and then we use a division algorithm. I'll tell you how to divide, children. I'll just finish the answer. So now by division algorithm, dividend, this is a dividend. This is a dividend is equal to divisor, which is a divisor. This is a divisor into the quotient plus the remainder. That's what you see here. Divisor into quotient plus the remainder. That's what you see here. By division algorithm, dividend is equal to divisor into quotient plus the remainder. And now how do you multiply these two? X into the second bracket plus 4 into the second bracket. That's how we multiply. X into the second bracket, 4 into the second bracket. X into the second bracket plus 4 into the second bracket. And then this plus 16x plus 1. Plus 16x plus 1. Now, we know that the value of x square minus 6x plus 1 is 0. See here, x square minus 6x plus 1 is 0. We know that. So, x squared plus 6x plus 1 is 0. You can substitute here also, children. You can also put it here itself. So, x into this one is 0, plus 4 into this one is 0. So, x into 0, 4 into 0, and plus 16x plus 1. So what is x into 0? 0. 4 into 0, 0. So we have only 16x plus 1. Now take the value of x. What's the value of x? X is equal to 3 plus root 8. Take the value of x. 3 plus root 8. So 48, 16 3s are 48 plus 6 root 8. 16 root 8 plus 1. So 48 plus 1 is 49. 16 and root 8 can be written like this, and 1 2 will come out. So 16 2s are 32, root 2. So the value of this expression is 49 plus 32 root 2. The value of this expression is 49 plus 32 root 2. See, you don't have to show the step also. See, you can, I'll just do the, when you write, you don't have to write it like this. You can straight away write in the next step, it will be x plus 4 into the value of this one is 0 plus 16x plus 1. So x plus 0 into x plus 4 into 0 is 0. 0. Okay, plus 16x plus 1. Then you should take the value of x, which is 3 plus root 8. Okay, now let's see how to do the long division. Let's see how to do the long division. I'll just correct this one alone. Using 1 because see here only we have x square minus 6x plus 1 is 0. We have called it 1. So using 1, we have substituted 0 here. So x plus 4 into 0 is 0. Plus 16x plus 1. So you're left with only 16x plus 1. Then take the value of x. So when you're writing, you write it like this. Now we'll do the long division, children. You have to divide by what? X square minus 6x plus 1. X square minus 6x plus 1. Okay, so how do we do the long division? The algebraic division. Divide the first term of the dividend by the first term of the divisor. Step 1. Step 1. X cubed by x square. What do you get? X. You must multiply this x. Now you should multiply this x with the divisor x square minus 6x plus 1. So write x here in the quotient and multiply this x with x square minus 6x plus 1. The first step is to divide the first term of the dividend by the first term of the divisor. And we get x. That's the first term in the quotient. Now multiply x with all the terms in the divisor. So x into x square, x cubed. Okay, x into x square is x cubed. Then x into minus 6x, minus 6x squared, x into 1, x plus x. That's all. Now change the signs because you'll have to subtract. Always division means subtracting only. So you have to change the signs. So plus becomes minus, plus becomes minus becomes plus, plus becomes minus. Now this gets cancelled. This is 4x squared. And minus 7x minus x is minus 8x. And this plus 5 comes down. Now the next stage of division. Next stage of division. What's the next stage of division? Divide 4x square by x square. Divide 4x square by x square. This is the next step. Step 2. 4x square by x square. What do you get? What is 4x square by x square? Yeah, anyone can answer. What is 4x square by x square?
4, mom.
Okay,
Four,
so that is the, yeah, that's the second term in the quotient. Plus 4 is the second term in the quotient. Now multiply this 4 with x square. 4x square. Multiply this 4 with minus 6x. 4 and minus 6x. 4 into minus 6x is minus 24x. And then multiply 4 with 1 plus 4. Always change the signs. Always change the signs. Okay, so how do you change the signs? Plus becomes minus, minus becomes plus, plus becomes minus. This will get cancelled. 24x minus 8x. 24x minus 8x is 16x. Plus 5 minus 4 is plus 1. Now, how do we know that we have to stop the division here? Because if you look at the divisor, if you look at the divisor, now normally when you divide with numbers, when do you stop the division? Like supposing you're dividing some big number, like some big number, you know, like whatever it goes, and you're dividing that by say 175. And supposing you get the remainder as, you keep dividing and you get the remainder as 32. You stop the division because the remainder has gone less than the divisor. You stop the division because the remainder has gone less than the divisor. In the same way here, when the remainder goes less than the divisor, but in algebra we say when the degree of the remainder, you will learn what is degree in the next chapter, polynomials. In the next chapter, polynomials. Now I'll just tell you in very simple language. Look at this x, the power is 1. Look at the x here. Here also there's x, power 1, power 2. The highest power here is 2, but here the highest power is 1. So it's become less, no, the degree is less. The remainder is less than the divisor. So you stop the division. Always we stop the division when the remainder is less than the divisor. Always we stop. See it here also. When you're dividing by 175, finally when you get remainder 32 and no number is there to come down, so stop the division because the remainder has gone less than the divisor. Same thing here. This is the remainder because the power of x is 1. Here in the divisor we have power 1 and 2 and the highest power is 2. So when you compare this 2 and this 1, 1 is less. The degree of the remainder is less than the degree of the divisor. So we stop the division. So we stop the division. Now we apply this is how we do the division. Now we apply the division algorithm. Dividend, this is the dividend. X cubed minus 2x squared minus 7x plus 5. This is the dividend is equal to divisor. X squared minus 6x plus 1 into the quotient plus the remainder. Plus the remainder. And after this, you know. Right on, children? So that changing signs only, you can see here in brackets. So you don't have to write it so far below. You don't write it below like this. You can write it here itself. Minus, plus, minus like this here. You don't have to put it here. I can't type it so close. That's why I put it down here. Minus, plus, minus. Yes, children, I'll come back in 5 minutes. Write down this answer. Done writing, children? All of you?
Yes, ma'am.
Yes, ma'am.
Yeah, with the corrections I made.
Yes, ma'am.
Yes, ma'am.
Okay. All right, children. So remember the procedure. When you see a question like this, you must recall the procedure. Whenever the denominator is irrational, you must rationalize it. So that will bring you to this stage. Once you start rationalizing, that will bring you here. At this point, have only √8 on one side and take this number to the other side. Now, you want to get rid of the square root symbol. You want to get rid of the square root symbol. 1 second, my son is shouting. Just a second. He's playing some video game, and not a video game, some game on the laptop, and if he wins, he goes mad. Okay, I'm sorry. So I was telling you, yeah, here. At this point, square on both the sides because you want to get rid of the square root symbol. That's a reason. See, I'm giving you a reason for everything that's happening here. So square on both the sides. When you square on both the sides, this is like a minus b the whole square. So a square plus b square minus 2ab is equal to 8. Now bring everybody to one side and you get a new equation like this. Now what to do after this? You want to connect this one and this one through long division, so that you can use the division algorithm and find the value of this. Okay, so you're taking this as this one alone, not equal to 0. This one alone you're taking as the divisor. And this you take as a dividend. Because power 3 is greater than power 2. So that the greater one will be the dividend. The smaller one will be the divisor. Like how if you have like 5 and 30, you know. So you prefer to have 30 as the dividend because it's bigger than 5. And 5 as the divisor. Here you can divide. Here you can divide 5 and 30 like this. But in algebra, you cannot divide. If you have x power 4 here and x power 5 outside, you cannot divide. If the degree of the dividend is less than the divisor, you cannot divide at all. Like with numbers, you can do. With numbers, you can do 1 divided by 4. And you can do, okay, 1 minute. I'll take a different number. Like if you have 17 by 33, you can take 33 inside and 17 outside. Or you can take 17 inside and 33 outside. You can divide both the ways. You can do 17 by 33 or you can do 33 by 17. But in algebra, you cannot do, the dividend has to be greater in value. The dividend has to be greater in value than the divisor, which means the degree should be more for the dividend than the divisor. So here, when you look at the powers of x, you have 3, 2, and 1. The highest power is 3. Here we have 1 and 2. The highest power is 2. So you can see here, the highest power is 3. Here it's 2. So this one is bigger than this one. Like the degree here is 3. The degree here is 2. So you cannot do the other way here. You cannot write this inside and this one outside and divide. That's not possible in algebra. That is with respect to algebraic expressions. So we do the division, children. So we perform the long division. And how do we know that we have to stop here? Because the degree here is 1 and here the divisor it is 2. So the remainder has gone less than the divisor. So you stop the division. And then you use the division algorithm. And the rest I think should be easy to understand. So like this we have found the value. So the value of this one is 49 plus 32 root 2. Okay. This is the next one, and with this, this presentation comes to an end. So we'll finish this and wind up the session for today, children. I think you first write it and then I can explain, because if I explain, it will take about 10 to 15 minutes and then you will have to scribble to write it down. So write out neatly, then I'll explain. Please write down this neatly. So once you have it in your book, then I can start explaining. Do it fast but neatly, children. Let me know once you finish it. Done writing, children? Are you all there? Please let me know if you're finished writing or you're still to write. Anirudh, finished writing?
No, ma'am.
Okay. Bhavishya?
No, ma'am.
Yes or no? Finished?
I'm not completed.
Okay, okay. Children, I'm right here. I'm just putting my mic on mute. Let me know when you finish.
Ma'am, finished, ma'am.
Yeah. All right, Abhishek. Okay, fine. Yes, children, it's also time. We have to start. Maybe you can take a screenshot and complete it later. Let's understand the working, children. Please stop writing and listen to me. Yeah. So we are given. All right, children. So we are given x is equal to whatever you see here. Now, as always, whenever the denominator is irrational, we have to rationalize the denominator. Ignore the numerator. Look at the denominator. It is irrational. So you have to rationalize the denominator. And the rationalizing factor or the conjugate of the denominator is or will be, write these expressions as you see. The connecting sign is minus. So in the conjugate, the connecting sign is plus. Right? When the denominator is root A minus root B, its conjugate is root A plus root B. Likewise here, write this one as it is. Don't change the sign here. Root of P plus Q as it is. Root of P minus Q as it is. The connecting sign minus is plus. If it was a plus here, then it will be a minus here. Only that sign will change. Only the connecting sign will change. All the others will come as they are. So x is equal to, write this expression as it is into, write the conjugate as we now understood. Write the conjugate. That's the first step. Now multiply the numerators, multiply the denominators. So you can see this. I've enclosed this numerator in a bracket and this numerator in a bracket. Multiply the numerators, and I've enclosed this denominator in a bracket and this denominator in a bracket. So next step is multiply the numerators, multiply the denominators. So that I've written the numerators in brackets. Now observe the the brackets in the numerator. You have the same thing. See here. Read this, it's the same. Read this, it's the same. And they're also connected by the same sign. So the numerator is something multiplied with itself. You can see that both these are the same in the numerator. So it's like something multiplied with itself. Observe this one and observe this one. Both are the same. Both are the same. So it's like a plus b into a plus b, which can be written as a plus b the whole square. So it will be this expression plus this expression the whole square. Because it's the same thing multiplied with itself. So whole square. That's about the numerator. The denominator, in the denominator, you see the same thing. See, these two are the same. These two are also the same, but the signs are different. So the denominator is of the form a minus b into a plus b. Why do we say a? Because see, this one and this one, they are the same. So a. This one and this one are the same. So like b. And the sign here is minus, here it is plus. So the denominator is of the form a minus b into a plus b. Check this one and this one, they're the same, a. Check this and this, they're the same, b. The signs minus and plus. So the denominator is of the form a minus b into a plus b, which is a square minus b square. This is a. See here, a square minus b. This is b square. A square minus b square. Now, in the next step, since the numerator is like a plus b the whole square, we'll have to expand it using the identity a square plus b square plus 2ab. All right. So see here, this is a. You can see a here, square. This is b, square. And 2 into a into b. A square, this is a, this is b. So you can see a square here. You can see b square here, and you can see 2ab here. A square plus b square plus 2ab. So that's how we expand the numerator. And the denominator, again, this one is like, what is this? Be very careful, children. This one, something the whole square. See, what is root 5? The whole square, 5. Okay, what is root a plus b, the whole square? A plus b. The square root is eliminated. The square root is eliminated. See, I'll tell you 2-3 times. Please try to understand. Supposing you have a plus b, root of a plus b the whole square. This is only one term. Square root of this one the whole square. So this is similar to root 5 the whole square. What is root 5 the whole square? The square root and the square gets cancelled. So the answer is 5. You don't cancel it. I'm just telling you, you can remember like that. So the square and the square root, they get cancelled. So the answer is a plus b. So here the square and the square root, when they get cancelled, so you get p plus q, minus here also the square and the square root gets cancelled. And it's p minus q. See, children, in the numerator, you cannot do that. In the numerator, you cannot cancel the square and square root because these are two terms. The square is for both. The numerator is like a plus b and the square is for both of that. So a plus b the whole square, which is a square plus b square plus 2ab. In the denominator, you see only one term. See here, root of something whole square. So the square and square root gets cancelled. Here also gets cancelled. So that's how we have P plus 2Q and P minus 2Q in brackets. Now simplify the numerator. Going back to the numerator in the next step, the square and square root will get cancelled. This and this gets cancelled. Okay, so you write this one as it is, this one as it is, then plus 2 into, this is like root A into root B. So it's root of A into B. This is like root A into root B. So root of, you can put them under the same square root and multiply them. You can put them under the same square root, root of A into B. So that's what you see in the next step. So here you can see that the square and square root gets cancelled. So you have this. Here also gets cancelled. So you have this one. And here you put both under the same square root in brackets like this. And in the denominator, you'll have to open the bracket. So P plus 2Q minus P plus 2Q. Minus P plus 2Q. So in the denominator, what happens? 2Q plus 2Q is 4Q. Plus P minus P gets cancelled. Plus P minus P gets cancelled. 2Q plus 2Q is 4Q in the denominator. So successfully, we have simplified the denominator. And you can see it's rational now. You can see that the denominator is now rational, 4Q. Now we'll continue to simplify the numerator further. Open the bracket. So you get P plus 2Q plus P minus 2Q. Open the bracket. So now 2Q minus 2Q gets cancelled. P plus P is 2P. And here, this is A plus B into A minus B, which is A square minus B square. A plus B into A minus B, which is A square minus B square. So you can see here P square minus 2Q the whole square. Here we open the bracket. Plus 2Q minus 2Q gets cancelled. P plus P is 2P. And here A plus B into A minus B is A square minus B square. So we get root of P square minus 4Q square. So here I said gets cancelled. P plus P is 2P. And then you can see the 2 here. You can see the 2 here. And this root of P square minus 4Q square. By 4Q. Don't forget the x is equal to children. See here x is equal to everywhere x is equal to. Now you can see this is a golden rule. Whenever there's something common, take out the common factor. So you can see that in the numerator, this is one term. This is another term. And both of them have 2 in common. So take out 2 as a common factor. Then you get P plus root of P square minus 4Q square by 4Q. Now 2 and this 4 will get cancelled. 2 and this 4 will get cancelled. So you will have only 2Q in the denominator. You will have only 2Q in the denominator. This 2 is cancelled out with this. Only 2Q you have, this 2 is gone. So you can remove the bracket in the numerator. So P plus root of P square minus 4Q square. At this point, you'll have to cross multiply. At this point, you cross multiply. So when you cross multiply, you have 2QX is equal to P plus root of P square minus 4Q square. So we learned in the earlier sum that since this one is an irrational number, root 8, we have this alone on one side and we take the others to the other side and we square on both the sides to get rid of the square root symbol. In the same way, here you can see that 2QX does not have the square root symbol. P also does not have. So like both are rational. This one has a square root symbol. So have that alone on one side. Have this on one side and take this P to the other side. For the same reason like the last sum. Have this one alone on one side and take this to the other side. Now you have to square on both the sides to get rid of the square root. Now square on both the sides. So you can see it here. When you square on both the sides, you get this one, the whole square is equal to this one, the whole square. So this is again like a minus b the whole square. So a square plus b square minus 2ab. A square plus b square minus 2ab. And here the square and square root will get cancelled and you have p square minus 4q square. Now we have finally got rid of all the square root symbols. So we are very close to the answer. Here this will be 4q square x square, p square. This is 2 2s are 4, pqx. And then bring everybody to the same side. So you'll have minus p square plus 4q square is equal to 0. Why we are bringing everything to one side? Because we've got rid of all the square root symbols. So get all the terms to the left hand side. Now when you do that, plus p square minus p square gets cancelled. So you're left with only these three terms, 4q square x square minus 4pqx plus 4q square is equal to 0. Now take out the common factor. Whenever there's something common, we take out the common factor. Now what is common? 4 is common. And then q square, q square. So q is common, not q square. So 4q is common. 4q is common. 4q is common. 4 and q is common. So in the bracket, you will get qx square because 4q is common. So you will get another q and x square. Here 4q is common. So px. Here 4q is common. So another q you will get in the bracket. So after taking out 4q common, this is the status. Now after this 4q will come for division. What is in multiplication here will come for division. So 0 by 4q is 0. 0 by 4q is 0. And we have got qx square minus px plus q is equal to 0, which is what we had to prove. So please practice this, children. See, children, practicing is very simple. It's as simple as this. You need to maintain your tuition notebook neatly. Practice only from the tuition notebook. Don't think, I've worked everything in the tuition, so why should I do it again? Let me work from somewhere else. That's not the way you study. You cannot improve if you do that. You have to only stick to your tuition classwork notebook. Do not use any other material to practice. Only then you will improve. Take it from me. If you ignore the tuition classwork notebook and study from somewhere else, you cannot improve. Now complete all the sums. So writing, going back to the assignment, that P by Q form, we have not discussed further. I want all of you to refer the method from the classwork notebook and complete it. Learn it and complete it. We'll discuss those answers in the next class. And also practice this one. Work this proof some 2-3 times by yourself. You can look at it and work it once, and then without seeing, work it 2-3 times. Then finally, you should be able to do this very fast, this proof very fast, without thinking much. Till that stage, you have to practice this. Now in the holidays, you have time. You can do all this in the holidays. All right, children, just one more minute. I'll stop the recording and I have to ask you something.